Hi, pre-calc class. Sorry to be out again and do this too, but I thought it would be a good idea to spend a second day working on 1.2 anyway. So what I'm going to do is go through and do out a few of the homework questions so you can sort of see if you were on the right track. And then I want you guys to spend some time working a little bit more on finding the nth term of a sequence when it's not arithmetic or geometric. So I'll leave you a few problems to try in your groups afterwards. But then, after you watch this video, go back, maybe take a second look at your 1.2 practice set and see if you can do some of the questions now that you maybe couldn't before, or you could try it after you do your group work. In the 1.2 exit slip quiz, those are the things I would like you guys to try for Wednesday's class, okay? All right, so the first part is find a formula a sub n for the arithmetic sequence. So when it says that, remember you're pulling from a sub n equals a sub 1 plus n minus 1 times d. And I'll go ahead and try 24 for you. So a sub n would be equal to a sub 1, which is negative y, plus n minus 1. I'm keeping the n, remember, because I want to create a general equation for this sequence. And then d is 5y. So after that, we just want to simplify. So I'm going to distribute. So negative y plus 5yn minus 5y. And then I can combine like terms. So we end up with a sub n equals 5yn minus 6y. Or you could do negative 6y plus 5yn. Exactly the same thing. Okay. So that would be your answer for 24. Here, when for 47, you're using that same formula, but this time they're giving you a value for n. So they're asking you to find a sub 7. So that tells me, okay, n is going to be 7. A sub 1 is obviously 4.2. And if a sub 2 is 6.6, then you have to figure out, okay, what is the common difference? So what did we do to get from 4.2 to 6.6? We added 2.4, right? So D is 2.4. So we would substitute all of this into your formula, and it's going to spit out just one value, okay? And then on the next page, we're using the formula for a geometric sequence. So a sub n equals a sub 1 times r to the n minus 1. You could also use a sub 0 times r to the n, but all of these are giving you a sub 1, so it's easier to do that. So first, I would substitute in 4 for a sub 1. Oh, sorry, I'll do 27. Times 1/2 to the n minus 1 power. So that's my equation for the nth term. And then it says find what we get when n is 10. So I'm going to find then a sub 10. So 4 times 1/2 to the 10 minus 1 power, or 4 times 1/2 to the 9th power. And I'm going to have to cheat here because I don't know what that is. So 4 times 1/2 to the 9th power. Yeah, 0.00781. So that would be your 10th term. If you wanted it in fraction form, you can do math and then number 1 fraction. And it gives you 1/128. Which would be another great way to answer that. Remember, the fractions are usually easier when we are dealing with the sequences. All right, so that takes care of the arithmetic and geometric sequence part. And then this part was the part that I suspected would give you a little bit of trouble. So I'm going to just do a couple of them to make sure you guys sort of get the idea. And then you can work with your groups to try a few more, okay? So let's look at 41. So it's negative 2/3, 3/4, negative 4/5, 5/6, and negative 6/7. So the first thing we're going to look at, again, I'm going to pick apart negative, positive, negative, positive, negative. So using that purple sheet there, I see that coming from -1 to the nth power. So that's got to be part of my sequence somewhere. 2, 3, 4, 5, 6. These are all adding 1 every time. So if I know it's arithmetic, I could go to my formula to figure out the equation. Or you can kind of think about it. If you're adding 1, if you're adding 2 to something, 2 would go before the variable, like 2n. If you're adding 3 every time, it would be 3n. If you're adding 5 every time, it would be 5n. So if I'm adding 1 every time, I know my equation is going to be 1n. But if I substitute in 1 for n first to get that first term, I'm not going to end up with 2, right? I need to get 2 as a value. So the only way I could really do that, thinking about keeping it like a linear style equation, would be to add 1 to that. All right. So I like to sort of guess and check it in my head, but you could also say, all right, well, this is 2 plus n minus 1 times 1. So 2 plus n minus 1 after you distribute that would just be n plus 1. So you get the same thing whether you're thinking about it in your head, like trying to think about it in slope-intercept form, or using the formula. It doesn't matter, but that's going to be my numerator. And then the denominator is 3, 4, 5, 6, 7. The pattern's the same, right? Plus 1, plus 1, plus 1. So I'm still going to have 1n in my equation, but I start at 3, not at 2, right? I'm starting at 3. So instead of adding 1, I need to add 2, right, to generate this. So my whole formula would be -1 to the n times n plus 1 over n plus 2. All right. You could put -1 to the n up in the numerator, like just multiplied by n plus 1, or in the denominator, or out front. It really doesn't matter because it's just a negative sign, so it's not changing the value. That negative could really go anywhere, okay? So that's a case where there were some arithmetic sequences built in. Feel free to use your formula if that's easier for you, or you can kind of guess and check, remembering that arithmetic sequences are always going to look linear, right? Slope with a variable plus a number plus y-intercept. So let's look at maybe 42 then. Let's see if I can. Oop. All right. So there's 42. So again, across the top, I see positive, negative, positive, negative. So that's -1 to the n plus 1 this time. It doesn't have to be plus 1 as long as you're adding an odd number. It could be anything, plus 3, plus 5, plus 7. It would still come out positive first. And then across the numerator, it's always a 1 up there. So I'm going to make my answer 1 over, because if something consistently shows up, then that's going to be part of my answer, okay? And then the denominator is 2, 4, 8, 16, so that's times 2. Again, if you notice it's arithmetic or geometric, we could say, oh, well, this is geometric, let's use that formula. Or look to your purple sheet. Where do you see a pattern of times 2? Well, it's in 2 to the n, right? So the denominator is going to be 2 to the n. Oops. And then that whole thing times -1 to the n, all right? You could just put -1 to the n in the numerator and 2 to the n in the denominator. That would be exactly the same. Whenever you need alternating sides, you have to have those parentheses around -1, otherwise everything is just going to be negative, okay? And then it's always a really good habit, once you think you've gotten the right equation, substitute in a couple of values for n and check and make sure it works, right? So let's say I want a sub 1. Okay, so if I do -1 to the first over 2 to the first, I get -1 over 2. Oh, I messed up my... See? It's a good thing I checked. It's supposed to be n plus 1 here. Boop. So that's positive 1/2, which is right. A sub 2 should be -1 to the 2 plus 1 over 2 squared. So that's -1 over 4, -1/4, which is what I wanted, right? So check a couple values and make sure that your pattern works for all of them, because often you might find something that works for only the first one, but it fails for the others. So let's do maybe, let's look at 48, maybe? Okay, so in 48, you notice that the first two terms here look different than the rest of them. But I always am going to try and put them in the same format before I decide on something that is going to cause a pattern. Before I start to look for the pattern, I'm going to put them in the same format. So the fact that the first two aren't fractions, but I noticed the rest of these all have 2 to some power, I'm going to just keep going with that pattern, but go to the left instead. So I'm going to make this 2 to the first power over something, and this 2 to the 0th power over something, all right? The denominator, I noticed 2, 6, 24, 120, that's a factorial, right? And if you look at your purple sheet, your sequencer there, the one that comes before 2 is a 1, that's 1 factorial, and the one that comes before 0 is also a 1. So if we replace the first two terms with that, it's actually pretty easy to see that your pattern is going to be 2 to the nth power. Maybe we'll finagle that in a second. And then let's try n factorial down here. Let's see if that works, okay? So when I substitute in 1, I would get 2 to the first over 1 factorial, which is going to be 2, right? Or 2 over 1. But that's actually what I have for a sub 2, the second term. So if I need to go backwards in a pattern on the sequencer on that purple sheet, if I'm going to go to the left in the sequence, right, from normally this is, let me draw it real quick. And factorial, we had 0, 1, 2, 3, right? So this is 1, 1, 2, 6. So normally, right, we start right here. But if I need to go one space to the left, then I have to take away 1 from wherever the variable is. And in this case, it's in the denominator with the factorial. So we actually want n minus 1 factorial. We're going to put the entire n minus 1 to the factorial because we're moving back one space in that pattern, okay? And then you actually need that to happen for the top as well, for the numerator, because we wanted to start with 2 to the 0th power, right? And we started with 2 to the first here. So if I'm going to do that with 2 to the n, right, that's 1, 2, 4, 8. I have to back that down as well. Then I want 2 to the n minus 1. So I'm taking away one value because I went left in the sequence one space. If you were to start at, let's say, 6 in n factorial instead of 1, and that meant you had to move up 2 spaces, then you would add 2 to the variable instead of subtracting. So this would be my final equation there, okay? Let's do maybe one more. You're probably sick of listening to me. Yeah, let's try 49. Oops. Okay. So the interesting thing about 49 is that, yes, you could simplify this. You could actually add those values together. 1 plus 1 over 1, we all know that's 2, right? The reason they're leaving it unsimplified is so that you can find the pattern. So try and resist the urge to simplify these. You want to leave it separate so you can find the pattern. So I'm going to draw my eyes to the things that never change. There's always a 1 out here. If there's always a 1 in the sequence, then that is going to be part of my equation. So 1 plus, there's also always a 1 in the numerator. So that's going to be part of my equation. The only thing that's changing, right, is the denominator here. 1, 2, 3, 4, 5. And since we're adding 1 every time and we start at 1, that's just generated by n, okay? So this whole equation is just 1 plus 1 over n. Again, yes, it could be simplified in here, but you wouldn't see the pattern really if you started to do that. That's why they're leaving it separate, okay? So try the problems I left you for your group. See if you can get the right answers. Be ready to share those on Wednesday, and the sub should have the answers to them so you can check. And then go back to this homework and try any that you maybe didn't get and see if you could do them now, okay? Good luck.